This video will talk about just basic simplifying of radicals. You can see a number of different kinds of radicals here, but what you should notice is that all of them have a number in the index, but in this case it's invisible. The number in the index here is a 2. The number in the index here is a 2, and those are both square roots, and that's what you will see most often. They're going to be square roots. Every now and then you're going to get a index of a number that's not 2, and you'll have to work with those a little bit differently. If you have something that has a coefficient out front, well, you will be busy simplifying this radical here. When you're all done simplifying the radical, then you'll multiply by a 3. That's all that means. So clean up everything that's in the red box, and then you can multiply that final result by 3. That'll be your answer in something like that. You'll notice that under the radical, the thing called the radicand, can be made up of a coefficient, which is just the numbers part, and then the separate variables part. In this case, I just have y's. In this case, I have x's and y's. Down here, I have a's and b's. And the key to simplifying any of these radicals is if you split them up, you'll be doing the same thing over and over again. In a problem like this, you have a number and one variable, so that's only really a 2-step. In something like this, you've got two variables, so you have 3 different steps there. If you do see decimals underneath the radical, you should pick up your calculator. It's safest to do decimals with the calculator. And usually if you're given decimals, they end up being perfect squares or perfect cube roots or perfect fourth roots. So let's talk about what these steps are. And we have numbers. The easiest thing to do is if you have perfect roots, if you have a perfect square root or a perfect cube root, you can pick up your calculator and let your calculator do it. If you look at all 3 of these examples, square root of 25, that's a plain old 5. You can do that with the calculator. Fifth root of 32, your calculator tells you it's a 2. Now on the Inspire, you'd be looking for the little button that allows you to change to this template. And that button on the calculator, it's right next to the regular square root button. You'll see it has an N up in the pocket here in the index. I call it a pocket. And so if you pull up that template, then you'll be able to put a 3 inside the index. You'll type in 729, and that will give you your answer. And so we'll pause for just a minute, give you a chance to practice that. Okay, if you don't get a nice answer, you get a lot of decimal digits when you go to try to pick up the calculator, then you're going to have to just simplify those radicals, and it's not hard to do. What you want to think about is that list of biggest perfect squares that we've talked about, and you want to find the biggest perfect square factor inside of 98. So the biggest perfect square inside of 98 is going to be 49. What's really happening is I'm splitting that square root of 98 into these 2 factors, and they're still both under radicals. But now on the next step, as you move along, you can clean up the square root of 49. When you do, it becomes a plain old 7. We'll just bring down that square root of 2. So this would be the simplification of the square root of 98. Square root of 128. I know there's a 64 times 2. 64 is the biggest perfect square factor inside of 128. So what's really happening is I'm splitting it up into square root of 64 and square root of 2. The square root of 64 will become a plain old 8. Now I'm often asked, do you need to show this step? Well, some people can look at these kinds of things and immediately come up with this correctly. If you can't, then you should be splitting it up, at least until you get the hang of it. Split it up and show yourself what's happening here. When you take the square root of 49, you end up with a plain old 7. The radical sign is gone, but this has no perfect square factors, so you just have to bring it down. And let's move over to now. So that's how you're going to work the numbers. If you have a root other than square root, that's a little bit different. I'll show you an example of that at the end. Well, variables are going to work very similarly to the numbers. You still have to do split. You still have to split up, but I think they're in a lot of cases easier than the numbers. Because you only have 3 cases, and in the variables it won't matter what is in the index. Whatever this procedure is, it's going to work for square roots, cube roots, fourth roots, any root. First thing, very easy to do. If your variable and your index divide evenly, 2 divided by 2 is 1, the radical's gone. 9 divided by 3 is 3, the radical's gone. And 21 divided by 7 is 3, the radical's gone. And so that's the easiest possibility you could have. Also easy is if your exponent in here is smaller than the number in the index, there's nothing you can do. You can just bring that down. If it is smaller than the index, there's nothing you could do. You just bring that down. That's as simplified as it can get. 2 is smaller than 3. That's as simplified it can get. You don't have to do anything more with that. Well, the most work, it's really not that bad though, because the most work, basically what you're doing is you're taking, when the number is bigger, 3, but it doesn't divide evenly, 3 divided by 2, then you're going to end up with a combination of this here and this here. And how you do that is you start counting down until the first number that does divide evenly. So 3 doesn't divide evenly by 2, but 2 does. So I'll split this up into a c squared and a c. Since there is an invisible 2 inside this index, 2 divided by 2 is 1. That radical is gone. And we'll just bring down the second part of it. H to the 5th and a 3 in the index. Well, 5 divided by 3 doesn't work. So we'll break that up into h to the 3rd under the radical sign and h squared under the radical sign. 3 divided by 3 does work. Now when you have a 3 in the pocket like that in the index, you have to keep the 3 in every part of the problem every time you draw a radical sign. 3 divided by 3 is 1, so that radical is gone. And this we're just going to bring down the cube root of h squared, and that's my answer. And I'm going to try to find room for that last one over here. I've got a 10 and a 6. Well, 10 doesn't divide evenly by 6, so we'll start counting down. 9 doesn't divide evenly by 6, neither does 8, neither does 7. But when we get to t to the 6, it does divide evenly. So I've got the 6th root of t to the 6th. I've got the 6th root of t to the 4th. In this case, now we have an even division. 6 divided by 6 is 1, so that comes out of the radical. And there's nothing I can do with this t to the 4th. We're just going to leave that as the 6th root of t to the 4th. And so you see an example of all 3 versions of simplifying. This last problem we'll look at is a cube root. Well, it's the numbers that are going to be different on a cube root. The variables work the exact same way regardless of what root you have. So let's look at the numbers part first. I'm going to split this up. It's the cube root of 192, and I'm going to create a separate radical for each variable. Cube root of x squared, cube root of y cubed, and the cube root of z to the 5th. When you have a root other than a square root, you know how to do the square root, you're looking for the biggest perfect square factor. But when you have a number other than a square root and you're looking at a number here, let's begin by trying to factor this 192. And we're going to take it down to prime factors. I know that this divides by 3. 3 and 19 is 6, 1 left over. It's 64 times 3, but that's not prime. Let's take it down to, well, we really don't even need prime numbers, but I'm going to go all the way down to prime numbers. 2 times 2 times 2 times 2 times 2 times 2 times 3. And that's what the equivalent of 192 is. So I'm looking at the cube root now of all these factors. This 3 says when I see a factor appearing 3 at a time, I can take it out front. So I'm going to see 1, 2, 3 2s. I'm going to bring a 2 out front. I'm going to see another 3 2s. So I'm going to bring a 2 out front. Now that's not 22, it's actually 2 times 2. And since I'm left with this 3 under the radical sign, there's nothing I can do with that. We're going to have to leave that alone. It's going to stay under the radical sign. It's a 3. 2 times 2 is 4. So I just changed that green radical into 4 cube root of 3. Let's look at the variables, which are actually easier. 2 is smaller than 3. There's nothing I can do with this one. It's just coming down. 3 divides by 3 evenly, so that radical sign is gone. It's just a y. You can write y to the first, just don't put the 1 in your final answer. And this last one here, that's one where 5 is bigger than 3, but it doesn't divide evenly, so I'll have to split that up. Start counting down from 5, and the first number you get to that does divide evenly is a 3. And don't forget, you need to have a z squared under here. Keep those 3's inside the pocket, inside the index. And now you've got this 2-part where now you have 3 divided by 3 evenly. That's a z to the 1st. And 2 is smaller than 3, so you'll have to bring that one down. Okay, everything we need is right here. We just need to go carefully to write our final answer. You can never have more than one radical sign inside of a term. So I'll make one radical sign. I might have a few things underneath it, so I'll make it long. Let's look for what's not under radical signs. I've got a, oops, let me try that again. I've got a 4, not under the radical sign. I've got a y, not under the radical sign. I've got a z, not under the radical sign. So I'm going to begin by making a 4y, z out here. We'll go in alphabetical order. And now I'll go back and pick up everything that still is under the radical sign. Don't forget, you have to have a 3 in the pocket there. And so we'll take numbers first. There's a 3. And I've got an x squared here, and I've got a z squared here. So I'll write the x squared, and I'll write the z squared. How much work you show on these depends on how much you can do in your head successfully. There's a lot of work written out here. That's so that you can see what's actually happening at each stage of the process. Remember, variables, it won't matter whether you have 2s or 3s or 4s or 17s. They're always going to work the same way. And the squares, if you have squares or no number in here, then you're looking for the perfect square root factors. But if you have anything other than a 2 in here or just a no number at all, then you want to start factoring into prime factors and pulling out this number at a time, putting it out front.